Okay, so you can see that I've gone ahead and activated my overlay data frame, and I've already dragged the Lockraven Streams buffer into this data frame. You can see my base data that I had in my other data frames, and you can also see my Baltimore County land use, which I've symbolized nicely here to kind of break out those different types of land uses. They're sort of grouped together. You can see that some of my higher numbers, my 20s through 25s, I've just said they're all just basically agriculture. 40 to 44 is different types of forest, even though each of those individual numbers mean a different type of forest. But this is Maryland Land Uses, Maryland Department of Planning's standard legend for their land use land cover data. So it does break out the land use data nicely. And one of the ones I did want to point out to you is going to be key. I'd mentioned earlier that I'm going to do just an intersect as part of the overlay, but I'm going to go ahead and do an intersect, and I'm also going to do a union. But what I'm also going to do is I'm going to do an identity. So identity is not listed under the geoprocessing common tools. So I'll do an identity over here, and I'll explain what that one is. And basically, each one of those different types of overlays is going to give us some different type of output. And so what's going to be key here for understanding this is that when we overlay these two layers, our Lockraven Streams buffer and our land use, we're going to wind up getting just the land use that falls within those critical areas. I did want to draw your attention to this particular polygon. I'm going to click here, and you're going to see, pardon me for just a second, I'm going to switch this to the Baltimore County land use layer, and I'm going to try that again and click in this very large polygon. You saw that a good chunk of the county was highlighted, and that's a cropland polygon, an agricultural land use, a 21, that has 18,793 acres in it. So that's a very large polygon. And so when we do an intersect with these polygons, we have to understand that the values, the attribute values from this input layer is going to be impressed upon, if you will, or imprinted on the output layer for the buffer. And that's going to be really key because we're trying to quantify what's happening inside the critical area. But we want to be mindful of the fact that if we're going to calculate areas such as square miles or acreages, that the original values from the land use polygons can get imprinted into those polygons, which could give us inaccurate numbers. So we want to make sure that we not only run the overlays properly, but that we inspect them and then do some data work afterwards, just in case it doesn't yield exactly what it should be. And you'll see what I'm talking about as we go on through the demo here. So I'm going to go ahead and right click on Baltimore County land use and zoom to layer, back us out a little bit. And again, there's our critical areas, all of our streams that wash into the Lockraven Reservoir. So the first overlay that I'm going to do, again, is going to be an intersect. So I'm going to go ahead and click on that. And I basically just need to tell the interface here what are the two layers that I want to intersect. So I want to intersect stream buffers, the Lockraven Streams buffer, and I also want to intersect the land use. And that's going to produce an output. And you can see I've done a lot of these other buffers and overlays earlier. So I'm just going to go ahead and say Lockraven Streams 500. And I'm going to call this one intersect so that I know I did an intersect when I did this particular overlay. So I'm going to go ahead and say save there. And I'm going to take the defaults here. The output types, you can choose line or point, but in this case I want output polygons. And then those join attributes, I want the attributes from the land use to come into the buffer once they're done being overlaid. So I'm going to go ahead and say OK there. And again, you can see ArcMap doing its work down at the bottom, and it did that intersect very quickly. So I'm going to go ahead and turn off the streams buffer here, and I'm going to turn off the land use for just a second. And so now you can see that what looks like that same buffer layer, but if I zoom in a little bit tighter, you can see all the land use polygons from the land use land cover. I'll zoom in a little bit tighter so we can really see how it's pulling those different shapes into just the 500-foot critical area. So again, I want to quantify how much of the different land uses there are within just that 500-foot critical area. But remember this big polygon from earlier. So I'm going to click on this polygon here, and I believe that's our 18,793 acre polygon. And so that's such a large polygon. The problem is, as part of this intersect, you can see if I turn this off, some of this cropland is actually going to wind up being within our buffered 500-foot area. So if I click on that polygon, again, it's picking up the Baltimore land use code now. So I'm going to go ahead and just switch that to visible layers. I'm going to close this for just a second and turn off Baltimore County land use, and I'm just going to click within my buffered polygons. And so again, just to get a sense of where that agricultural land comes through, it cuts through here, so this is going to be one of those agricultural polygons. But when I click on that polygon, look what it does. I messed up again here, Professor. What's going on? Clicking on my... I'm clicking on my base data. I'm going to go ahead and turn that off because I don't want to use the identify tool. I only wanted to identify what is visible in that particular layer. I could also isolate it to just say I only want to eye tool on the 500 intersect. So bear with me as I kind of get sorted out here with lots of different layers in my data frame. But again, if I click here, you can see all these other polygons get selected. I'll click again, see how they're being highlighted. That's what's called a multi-part polygon. So originally they were part of this much larger single polygon, but when we did that intersect, they became what's called a multi-part polygon. And so if I click on this one polygon, I can't get an area on that polygon that is accurate because it has basically imprinted the attributes from the land use onto all of these different land uses that fall within the 500 foot buffer. So this acreage is now inaccurate. So one of the things you can do to combat that is you can remove a lot of those fields and just recalculate areas such as square miles. You can see my square mileage here. I'm going to go ahead and delete that actually, since I said that. It cannot be undone. Okay, I'm a highly trained professional. I'm going to go ahead and click on acres as well, and I'm going to delete that. And so now I'm back to having no calculated acreage or square mileage for these polygons. And again, so if I click here, I still have that problem where it's clicking and having a multi-part polygon even though they're not adjacent to one another. So what I'm going to do here is I'm going to use my edit tool. And you guys are familiar with your edit tool from earlier modules, digitizing and editing attributes. And so I'm going to say start editing here. And I want to edit my intersect. So I'm going to go ahead and say OK there. And one of the things I can do here is I can bring up this more editing tools interface and go to advanced editing. And so what I want to do is basically explode any multi-part polygons in this layer into individual polygons. So again, if I click on one right now, you see it's a multi-part polygon. Lots of different polygons are making up that one record in the database. If I select it, same thing, and I open up that intersect table, and it is one record in that data layer. So that's problematic if I want to try to calculate some sort of acreage. So what I'm going to do here is I'm just going to deselect all of those, and I'm actually going to go ahead and open up the table on this and come into my table options and say select all. That allows me to select every record in that database. So I'm going to go ahead and zoom to layer, and you can see I've selected everything in that buffer. Now that one polygon was not the only multi-part polygon. There might have been other multi-part polygons throughout the entire data set. So what I want to do is I want to use this particular tool. You can see there that it says explode multi-part feature. So I'm going to zoom to previous here back to where I know I have one of those agricultural polygons. Okay, there's my my 21, so that's one of my agricultural land uses. And when I click this button, it then explodes it out, and now I can click on that one individual polygon. And so that's going to give me, I'm going to recalculate areas now for each of these individual polygons. And so I won't have any inaccuracies in terms of my calculations. That way I can actually quantify properly, in the correct way, the amount of acreage that is yielded within that 500 foot buffer around all the streams. So I'm going to go ahead and say yes to those edits. I'm going to go ahead and turn off my editor because I don't need it now. And I'm going to zoom back to the extents of that layer. And so now what I want to do is I just want to use my calculate geometry tool. I'm going to open up the table, and I'm going to put a new acres field in here. And I can put a new acres field in here called acres because I've deleted the other one. And so I'm going to come in here and I'm going to say add field. I'm going to say acres. And I'm going to make this a float because I'm going to use at least 2 decimal places. And I want to make sure that I make it a nice big number because there could be some polygons that get pretty large there. So I'm going to make it at least 10 digits overall, and then 2 digits to the right of the decimal. Including the decimal and the 2 digits, that's 3 spaces. So that leaves me 7 left of those 10. So out of all of these polygons, there's probably not going to be any that are going to be in the millions of acres. So I think I'm okay with 10 and 2. If I wanted to be sure, I could just make it 11 and just make it one more digit wider, which is going to be plenty for calculating acreages. So I'll say OK. And so what I'll do here is I'm going to calculate those acreages using the Calculate Geometry tool. I'm going to go ahead and say yes here. And I want to calculate area. It knows what coordinate system it's in. It knows what units we're using. So when I tell it to do acres, it's actually going to do the conversion for me. And I'm going to go ahead and say OK. And so now I know for each of those individual polygons how many acres of the different types of land uses exist within that 500-foot critical area of all the streams leading into Loch Raven. So if I go ahead and do some basic statistics on this, I can see that there is a total of over 31,000 acres that fall within that 500-foot buffer around the streams. And another thing I can do here is I can actually quantify by the different land uses. You can see that some of my land uses are not defined because I've not done that data work there from one of my earlier demos, but I do have a code in here. And I do have a resource document that tells me what each one of those codes is. So I can just go ahead and say, I'm going to right click on LU code and I'm going to say summarize. And what that's going to do is it's going to write out a new table that's going to tell me how many polygons of each land use code I have, A, and then of course I can tell it to summarize my acreage for each of those different types. So for each different land use, it's going to tell me how many acres of each I have within that 500-foot buffer. So all my 41s, my deciduous forest, my 22s, my 21s, each will have a count field that tells us how many polygons, and then it will also tell me the total acreage for each of those different land uses. So I'm going to go ahead and send that out to my output folder. I want to make it a DBase table. And just like earlier, I did a summary of my underground storage tanks. I'm going to do my land use summary here. So I'm just going to call that lusum.dbf, and I'm going to say save. And I'm going to say OK. It runs that very quickly. I'm going to close this out, and that gives me a new table that it automatically adds into the data frame. So when I say open, it's going to give me a rundown. Whoops. Let me reopen that. I'm going to unpin that. I do just want to, there we go. I just want it to float out there in the middle. So I'm going to right click and sort land use code. So this tells me low density residential, high density resident, or medium density residential, high density residential, commercial, the different types of cropland. I have deciduous forest, I have mixed forest. And so what that tells me, using our 21s for example, I've got 531 polygons within this 500-foot buffer that has a total acreage of 6,107 acres around my critical area. So being mindful of the output that each of these different types of overlays produces is going to pay off in the end, so you actually do proper calculations. I'm going to go ahead and remove that LU sum, and I'm going to switch back to my list by drawing order layer. So that was my intersect. So what we're going to do here really quick is just look at a union. So I'm going to go up to Geoprocessing, and I'm going to say union. And what that does is basically takes all the features of one layer and merges it with all the features of another. And before I do that, actually, I just did want to show you one thing that would be really key. I'm going to open up the attribute table. You see that this is my buffer layer, and I have basically no attributes there, and that's just that one polygon. So if I turn that on, that's the one big polygon that we're talking about. I want to give a little bit of information here, though, to this big polygon. I'm going to add a field in here called critical, and I'm just going to make it text, and I'll make it 1. Maybe I'll just make it 3 digits wide or 3 characters wide. And so what I want to do is I want to calculate that to be yes. That is critical area. That is my 500-foot critical area. So in quotes, I'm going to put a yes in there. Actually, I made it 3 characters wide, so I can actually make it yes and say OK. And so when I do this union, what's going to happen is it's going to take all of this one big polygon and union it, or merge it basically together with all the polygons in the land use land cover. And that's going to give us a slightly different result. Actually significantly different result than what we did with our intersect. Remember, our intersect only kept what was common to both layers. In fact, I'm going to go ahead and undo the remove layer. I wanted to be able to show you the difference So I'm going to turn off that intersect for a second, and if we come down here, we can see that I've got my land use land cover that comes straight down here. This is the county boundary. And so when I did that intersect between the buffer and the land use, it only kept what was common to both. So it did actually trim off that little piece right there because that's outside of the county boundary. So a union is going to be slightly different. So I am going to go ahead and keep that 500-foot buffer intersect so I can kind of compare the different outputs that we get. So I'm going to zoom to layer here, and I'm going to go ahead and run that union now. And my input is going to be my original buffer, and my other layer is going to be my land use. And my output here, I'm just going to kind of borrow the name here, but instead of saying intersect, I'm going to say union. So I know that that's my 500-foot union between those two layers. I'm going to go ahead and take the defaults here and just let this run. And so that union is going to produce something remarkably different in that my original intersect only produced an output that was common to both layers. A union keeps everything from both layers. Now, you can imagine that's going to create a big mess. So again, coming down here to my sample area, I had my original 500-foot buffer. I had my land use land cover. I merged those two together, and it gave me a union. But now I have all of those polygons from the buffer basically imprinted into the land use. So when I click on any one of those polygons, it's going to tell me whether it's critical or whether it's not. So now if I click over here in an area that is not critical, I know that that is not within that 500-foot critical area. But if I follow my buffer along here, and I can click on any one of these polygons within here, and again, that's where that adding that field into the buffer layer was very key and very useful. So now I can actually come in here and do a query against that layer, against that union layer that says, show me the areas that are critical. And I've got yeses and I've got blanks. So if I double click and I say yes, it's going to highlight everything within, just zoom to layer there. And there's my familiar buffer. Now I would want to also investigate, like I did earlier with my different land uses, if I have multi-part polygons. And you can see I click there and I do have multi-part polygons as I tool here. I pick up these polygons. So I would want to go through that explode features process again if I wanted to recalculate areas. So I'm not going to go through that process because you've seen it once before. So I'm just going to go ahead and zoom to layer here. And again, just reiterating that the union is going to keep all features from both inputs. So I'm going to go ahead and turn that off, and I'm going to do one last one. As I mentioned, we did the identity, or we talked about doing an identity. And so the identity, you can see, is slightly different. It's going to keep all of the features of one and only what intersects of the other. So in this case, I'm going to say that my input is going to be my buffer, and my identity features are going to be my Baltimore County land use. And I'm going to go ahead and take the defaults there, but again, I'm going to come over here and borrow the name from one of my earlier files, and I'm just going to call this underscore identity so that I know that that's my identity layer. And I'm going to go ahead and say OK. So when it runs that identity, it's automatically going to add in my output. And again, I'm going to turn on the original buffer here, and you can see that in this case it only kept everything that fell inside of the buffer. All right, whereas my intersect cut it off of what fell outside of the county. And then of course my union kept everything. So depending on what you're doing and what you need your analysis sort of to yield to or to create, you're going to make a choice between these different types of identities. But here we're basically looking at combining multiple layers into one to further our analysis. And again, not unlike my union, not unlike my intersect, I could have multi-part polygons, and there's an example right there. I'm just clicking on that one polygon, but you're seeing that all these other polygons are being selected. So if I wanted to get individual acreages for those polygons, I wanted to make sure that I explode that out to its individual parts using that advanced editing tool, and that I recalculate the acreages. So those are different ways that we can use the different overlays. And again, if we went into the intersect layer and open that up, which is the one that actually we did run through that explode polygon process, and I created that new acres field. Again, we can quantify and find out how much of these different land uses are within the critical areas, and then of course we can start making some decisions on that. Maybe we can start to target certain types of land uses that we want to preserve, other ones that we want to try to revert, maybe taking a certain type of land use back to forest, do some reforesting so that we can help the water quality situation within Loch Raven. So again, just giving you some context for the different processes here. But that's going to basically wrap up the different demos that I have here for the dissolve, the clip, the buffer, and the overlay processes. And of course, you're going to get to practice these within chapters 11 and 12. So I recommend go ahead and moving into those. Take your time and go through those, because those may be some analysis tools that you want to use as part of your final project, project number 2. And if there are any questions, please contact me.